So yeah, for the next 30 minutes or so, I'm going to talk about WebMvc.fn and also a little bit about WebFlux.fn. So these are both part of Spring Framework, and these are what we call, what you can create with them is the so-called functional web endpoints. And yes, my name is Arjen Poutsma. I now work for VMware again. Yes, have been working on Spring for about 15 years now. Not the oldest, but definitely one of the old farts on this group. So what I mean with functional web endpoints, right? Functional web endpoints are basically a framework containing of two central types. One central type is called the handler function, and the other central type is called the router function. And the first introduction of this whole idea, this whole concept was done in Spring 5. So that's, I think, 3 years ago now almost. In the form of WebFlux.fn. So in Spring 5, we introduced WebFlux, right, our reactive web model, next to the alternative, the servlet model that we already had. And part of that introduction, we introduced this functional programming model, and people liked it so much, or some people at least, that they asked for us to do it the same, but then for the servlet model. So that's what we did in Spring 5.2. We introduced Spring WebMvc.fn. So that's simply the same sort of programming model, but then a functional programming model, but then not really asynchronous and not really reactive, right? You can do asynchronous stuff with it, but it's not really the foundation. Well, with WebFlux, right, it's meant to do handle reactive code, and it can also do synchronous code. With the servlet model, it's basically the other way around. So both of these models are fully supported in Spring Boot. And what that exactly means, I'll tell you in a minute. But it basically means that you can just write router functions, and they will be picked up by Spring Boot and exposed. So I'm going to make a lot of comparisons basically with Spring MVC, right? The annotation-based Spring MVC, because I think that's what most people know and recognize and love. So I'm going to start off with Spring and WebMvc, and then show you how it compares to WebMvc.fn, right? So here we have, and we're going to start off with the handler functions. So what are handler functions? Well, it says here, they map from a server request to a server response. And mapping basically means that you have a sort of a fancy functional lingo for, you have a method and it takes a server request and it returns a server response. Now here we have a controller, right? So let's say WebMvc controller. What it does, it's very simple. It just does a little bit of REST-like interaction with exposing on a person repository. We have a getPerson method requiring a path variable. We use that ID, and we use that same ID to look up a person, and then we return a response entity with the status code 200, okay, and say content type is application JSON. I want to marshal this or serialize this to JSON, and then make the body contain this person that I just looked up. And then we have another method called getPeople, and basically we look up the people, all the people, and in the repository, and we do a similar thing as we did before. So these are handler methods, right? That's in a controller, you have these handler methods in a MVC controller, and they handle the particular request. So what are handler functions then? Well, they look sort of similar. I mean, this is just, by the way, one way of doing this. There's a lot of ways to get to the same, right? We could have written a REST controller and return a person directly instead of creating a response entity. But this is just this gives you just a nice comparison to handler functions, which I'm gonna turn over to now. This is the WebMvc, so it looks fairly similar, right? We still have a controller class. That basically means that the handler will be picked up by Spring MVC or by Spring, the dispatcher servlet, just like other controllers are. It has a repository, but now we have this other method here, and this is what it means when it says it maps from a server request to a server response, right? We have this method here, getPerson, taking a server request and returning a server response. And that's something you'll see when using WebMvc.fn or WebFlux.fn, that's basically what you'll see forever. You take a request and you return a response. There are no variable method signatures as you have in annotations. Now, so what we do, we take this request, and rather than using an annotation as we did before to get the path variable, what we do here is we basically query the request for the path variable. So we get the path variable ID, and then we look up the person. So the rest of the code is pretty similar as we had before. The only thing is that we now return a server response instead of returning a response entity, but the rest looks pretty similar. So from this perspective, it's not that different, right? And I'll put them side by side here for you so you can have a nice comparison here. If you're using response entities in Spring MVC, then it's not so different from writing handler functions. But once again, you can do the left-hand side on a lot of different ways, right? You could do the same thing with, once again, REST controller or returning a person playing with the add response body annotation. Spring Web MVC basically has a lot of ways to accomplish similar effects, and basically whatever fits the particular scenario is the one you should pick, or whatever you like. So this is the comparison. I also said I'm going to talk a little bit about WebFlux. So here's one of the slides I have for WebFlux. In WebFlux, what you would do in a controller land, right? In Spring WebFlux, you would basically return, rather than returning the response entity, you would return a mono response entity. And rather than returning a list of people, you return a flux of people, right? Now, I only have 30 minutes today, well, even less now, so I'm not going to go into reactiveness that much in this talk. If you want to know more about this model, then I have a lot of presentations available online at Spring.io and Spring One platform about this particular framework, and also WebFlux.fn. So if you want to particularly interested in WebFlux.fn, then you should look that up instead of listening to this presentation. But on the right-hand side, we have we see that what the difference is. We basically see that in the WebFlux.fn, we were still taking that server request, so we have the same sort of input, but we now don't have the well, we're returning a delayed response. We're returning a mono over response, right? A future response, basically. And that's because the repository gives us that, right? We don't get a person straight away. We get a mono of a person, and we flap map on that mono to create a response. Now you can complicate this, saying, okay, what's the mono is empty, and what do we do in that case? Well, that's something I cover in this other presentation. So look that up if you want. Same thing on the get people method. You can see that they're still sort of similar, right? You still have that asynchronousness in it, and both sides need to deal with that. So once again, handler functions, not that different between Spring MVC when they're creating response entities. It's fairly similar model, more or less. The only difference is that you have a lot more flexibility in terms of the method signature on the annotation side. So summarizing for handler functions, they map from a server request to a server response. They are both server requests and server response are immutable, right? This is one of these pillars of functional programming, immutable objects. So that means you typically get builders to create your objects, and then once constructed, they are immutable, so you can't change them. There's no setters. So you use a builder to create a response. And if you are dealing with WebFlux, when you're working in WebFlux, then you basically have to return us a mono over server response, so a future response. Now the second part, right? This is hopefully going to be more different than Spring MVC, annotation-based, because the former part was a bit the same. So this is the part where we're saying we're going to talk about router functions. Now, routing in the annotation WebMvc, you do that with the add request mapping annotation, right? So you say add request mapping people. In this case, you map the whole class, the whole person controller to people. Underneath there, we have the get person method, and then we say, well, for this method, it should append that /id path variable to people. So we end up with /people /path variable ID. The method should be get, and I left out the body of the code here because it's not that interesting. And the same applies to, well, for the get people, we just have a method, a request mapping method. We don't need to supply a path because the path is sort of inherited from the people, the type level annotation, basically. So that's basically how you do it in WebMvc, how you do it in annotations. So what does it look like in WebMvc.fn? Well, this is where things get a little bit different, right? So rather than using annotations, we're creating a get person and get people method. We still have those. Those are the same. And we're creating a static bean. So this bean is actually detected. This router function is detected by Spring WebMvc, and it's also by Spring Boot. And it will basically say, oh, this is a router, so I should basically probably support that and make sure that all the routes that it supports are registered in this particular servlet. So we're creating a router function based on the person handler itself. And then we use a route builder. So we say route and then period get, and then we provide a path, say /person/id, and we map that to the method reference of get person. So that's where we map the, that's if you've never seen it before, I'm guessing people nowadays should have seen it before because it's standard Java 8 stuff. Method reference is basically, you're calling a function. So in this case, it's a handler function, but instead of supplying the handler function inline, we're just going to refer to a method. So we're referring to get person on the person handler. And we do the same for get people. We're mapping to the get people method. It's just above it. And then we say build to build the whole route. That's what we do here. But there's a little bit room for improvement, right? If you go back, then we see we didn't have to supply the people part twice. We only had to supply the /people part at the top, and then we supplied it. We basically let the other two inherit it. So here we have some duplication. Well, in this case, it's only 2 methods, so it doesn't matter that much, I would say. But you can imagine that this will build up if you have a big handler, big controller. You'll have more than 2 methods. So, and they might share the same prefix at least. So you want to do something about that. And we actually do support that. So we support something we call nesting. You can nest routes. And this particular nesting that we do here with path is a very particular kind of nesting. I'm going to talk later about other kinds of nesting you could do, but this is by far the most common. So we nesting here based on a path, we say /path /person. So everything then that's built by the builder that's supplied further, right? So everything that's basically aligned slightly to the right, 2 spaces to the right, that's basically gets nested into this /person prefix. So you'll end up with pretty much the same thing. You'll end up with /person/id mapping to get person, /person mapping to get people. So putting them side by side is probably the best idea to make a fair comparison, right? On the left-hand side, we have WebMvc with the annotations. On the right-hand side, we have WebMvc.fn. And then here I have some arrows to actually show you where everything goes, right? Where each part ends up. So I'm going to look a little bit at questions. I'm most questions are actually going to be coming up. So one thing about the threading model in WebFlux, how many netty threads are there? That's basically reactor netty. So that's what we use underneath. So that's standard netty installation. We don't create standard. It's the same as in other WebFlux applications. There's no difference here with the functional model. So that's answered. So the router function that we see so far is we're using a builder, right? So we're using here, we say route, open, basically no arguments. That basically gives you a route builder, and then we call path and get on it, and we end up with this builder model basically. Now this builder model basically, it gives you an abstraction, a sort of a simple abstraction over the underneath the model that's underneath, which is actually a bit more powerful. So if you ever find yourself in a scenario where the router doesn't give you everything you need, I would definitely recommend using the router. but it's going to be a little bit underneath. Well, I'm not going to recommend it basically as for typical usage. And if you find out that you can't accomplish something, you should probably look at the more powerful abstractions that are given you underneath. So the builder gives you a get, a head, a post, put, match, average, standard HTTP methods, right? It also gives you ways to map resources. So you can just say, give me a path and a map resource accordingly, or you can do nesting as we've seen. But there's also another thing you can do. You can actually, for each of these methods, so here we see this method signature, but there's something different here. This is the one we've been using so far where we said get and then a pattern, but here, and then a function, handler function, but here there's also the opportunity to provide a request predicate. And that's basically one of the foundational building blocks of this model as well, right? A request predicate is something that maps, once again, from a server request to a Boolean. So it just says, given a request, is it true? Give me yes or no, basically. And you can write your own request predicates. You typically don't have to. You don't have to. We provide a lot of them that for the standard things you want to test against. And what are things you want to test against? Well, you want to test against the HTTP method, right? This builder method right here at the top actually uses the get request predicate underneath. You want to test against the path. You might test against the path extension, right? You want to say, well, I want to map /people, but then all TXT extensions or query parameters. Or you might want to test against headers, specifically content type and accept headers, and even do some composition, right? This is basically one of the foundational building blocks of functional programming is this compositional style, where you can say, I want to make something reach a particular method when this header is here and also this query parameter, but not this accept header, right? So you have the accept, both the and or operators and also the negation operator. So what does that mean? How do we use it? Well, let's look at another example here. I'm starting off with WebMvc.fn. So I added a create person method to show you how you can also do uploads, right? So here we have a server request, a create person method where we say request, and then given the body, convert the body into a person, basically. So that's probably going to be JSON, right? Deserialize it, save it in a repo, and then return an OK response. And you'll see that we are mapping that below, but you see that we also added something else. So here now all these things go accept application JSON, accept application JSON, and content type application JSON. So what that means basically is that whenever a method occurs or a request occurs that has HTTP method get, and the path is /person/ID, and the accept header contains JSON or is compatible with JSON, then invoke get person, and etc. for get people, right? We also need the accept header here. And the content type is basically the reverse, right? We check the content type of the posted stuff and then see if it's JSON. You can nest with these predicates. That's pretty awesome. You can do saying, okay, well, we have some duplication here once again, right? We see the accept application JSON used twice. So why not nest it? Do it once, right? I'm not sure if I would do it once again for only 2 handlers, but there's cases where you have a lot of them and you want to deal with all of them in the same fashion. So you can nest according to this. What does it look like in MVC, right? In annotation-based, how would you do the same thing? Well, you would probably use produces, right? The produces element of the annotation. That doesn't do the exact same thing. That does a lot more actually. Produces and consumes elements of request tapping. They basically do content negotiation, real content negotiation that you can configure. You can say, I want to check the accept header or not, and I want to look at the file extension or not. The model on the right-hand side is a lot more simpler. It basically says, I'm going to check for the accept header. If you want to check for the file extension too, you should use the file extension request predicate or combine them. Basically say, if the file extension is JSON or accept is JSON, then invoke this one. Otherwise, invoke that one, right? So composition becomes quite interesting, becomes quite important. Now, this nesting that I did with application JSON, right? that's not something you can do easily in MVC. I mean, since you're basically stuck to whatever you can put annotations on, so you have to, maybe you create a special subtype where you have special annotations. You could do it, I guess, but it doesn't really look as elegant as I think on the right-hand side. So stuff like this, more complicated mappings where you want to combine this stuff, that's really where MVC.fn is really tailored to. Finally, or not really finally, I'm gonna talk a little bit more, but this is the last thing I want to talk about, the handler filter function. Basically, it's a whole mouthful, and the subtitle isn't much clearer either. It says maps, server request, and handler function to server response. So I already saw that a lot of people had questions about exception handlers. So that's basically where this comes in, right? If you want to, handler filters, among other things, are useful for dealing with errors. So here we have another MVC. We're using exception handler to handle a not found exception, and then we return a response entry where we say not found. The same thing you can do in WebMvc.fn. You would say an on error, right? You can see it, well, just above the build stage, the build step there, next to last. You say on error, not found exception, and handler not found. And this can be a lot more flexible, right? The first premise is actually a predicate, so you can say any kind of tests you can do on an exception, not just the type-based, but any kind of test. And just like with nesting, we can put this anywhere. It doesn't have to be on the same level, right? Here, this exception handler is applied to everything in the same controller. Here, I can move it around. I can say, let's move it there. So now it only applies for those two get methods, right? That's the scope now of that filter. So the filter doesn't really apply to the post, and the filter only applies to the error. So once again, the comparison here is fairly easy, right? You have an exception handler on the left-hand side with the WebMvc, and on the right-hand side, basically you have the on error. And this is just one example of filtering, right? This is just a particular error filtering. You can also do more typical servlet filter stuff, like you can map a request on a request, so you can filter the request, add more headers to it for particular methods, remove headers. You can also do, not that I recommend it, but you could do very simple security light stuff. You could actually say, well, if there's not this header, then it should not progress to the next handler in the chain, right? There's a whole sort of servlet filter handler interception style mechanism here that you can use. And it's exposed both in the builder, but even more powerfully so in the underlying abstractions. So this is sort of my final comparison, where because I think that some questions, some people are asking, so where is it useful? That's hard to say for me because I don't really know what kind of applications you're building, but I'm trying to basically give you sort of in my mind at least, the final comparison between the two models. So on the left-hand side, we have annotations, right? The WebMvc is basically built on annotations, and WebMvc.fn is built on functions. That's sort of the starting blocks of both of these frameworks. So what that means basically, in annotation land, you have metadata, right? So that's the way you express your concerns. You express the request parameters, you express the parameters of your method, right? You can use stuff like path variable and request body and response body to express what you want the method to do. On the right-hand side, in the functional model, you don't use metadata, you use code. And we used a lot of shortcuts today, right? All these given request predicates, these are basically built in. But underneath, that's just simply code, right? Any of those accept calls that I did or consumes, you could debug that. You could do, well, in IntelliJ, you could do Command B and just zoom into it. And basically look what it does. And if it doesn't do what you want, you can write your own request predicate, because there's no real difference between the predicates that we provide in Spring and the ones that you provide for your custom solution.
2 more minutes, Arjen.
Yeah. No, it's fine. This is my last slide, basically. So the annotation-based model, it's a lot more flexible as a consequence, right? You can add any kind of parameters to a method. You can even write your own annotations and so let them be supported by Spring MVC, and even write your own return value handlers and stuff like that. So this is a very flexible model. But the right-hand side, right? It's flexible in the sense of what you can provide in metadata, if you know what I mean. The right-hand side, it doesn't have that same problem. It's more rigid, right? You don't have the flexibility when it comes to method signatures, but you can get the exact same information out of the request that you can get through methods through parameters. So like we saw with the request parameter, basically the path variable, that's just available on a request. Same with request parameters, etc. But the routing possibilities on WebMvc.fn are a lot better, you can do basically anything that you can do in code. And if you want to do that in MVC, I mean, it's possible, but you have to write your own annotations and handlers for those annotations as well. So now I have, I don't know, 1 more minute, I guess, for questions.
Yeah, roughly 1 minute.
Right, roughly 1 minute. Well, I'll stay around. I don't see any particular question that pops out to me at this point. So.
Yeah, but there's been healthy interest in this talk. A lot of people are very eager to see how to move to a more functional approach on the web layer. Obviously,
yeah, I mean,
have been answering a lot.
All right, well, that's great. I asked them to to help me, so that's great that they helped me. One funny thing is that there's no real choose. I mean, choose whatever you want, right? We have always provided multiple web models, right? Back in the day, we had an inheritance-based controller model, and then we started doing the annotation-based model. Now the inheritance-based model is gone these days. Well, it's still sort of there, but it's not that extensive as it used to be. And this is sort of the same thing. We have both, and we're going to support both for well, for as long as I'm here.
The future.
Yeah, for the foreseeable future, exactly. So that's all I have time for. Thank you very much for the interest. I'll stay around and answer some questions, but